Yours.
So everyone who needs it, it's on. If you don't need it, then here we go. All right. So again, are we good now? Yes. Okay. Your notes. It's supposed to be a booklet, but the inside is upside down. I was rushing to make the copies, so the inside is upside down. So just be prepared to flip. Okay. All right. So it's a booklet. We're on the outside. You should have made a booklet. Because it's a booklet. Oh my gosh. I'm not doing this again. All right. Here we go. Adding polynomials. So adding polynomials is essentially just combining like terms. Do you hear me? All we're doing is combining like terms. Remember, like terms have the exact same variables with the same power. There are two visual ways of solving this. Method number one involves you just simply going horizontal. So horizontal means, okay, or not. Try that again. So horizontally means you just look and see what are the like terms. I have 2x squared and I have 1x squared. What does 2x squared plus 1x squared make? 3x squared. I have 3x and negative 5x. What do they make? Negative 2x. I have 2 and I have negative 5. What do they make? Negative 3. That is horizontal. On the outside of the booklet. Hold it. Okay. Okay. All right. So, yes, easy enough. Okay. The vertical method is where you rewrite them and stack corresponding, and then you add vertically. So 4AB is a positive 4AB and would go under the other AB. 6B squared would go underneath negative, and then you go vertical. That's it. All I did was move it, and now we're going to add. 3A squared had no friends. I have 3AB and 4AB, and that makes 7AB. I have negative 1B squared and positive 6B squared. What does that make? And bam. That's the vertical. Does it matter which way you do it? No. Okay. How do we feel about adding? Questions, comments, concerns?
I have a question.
Yes.
Will the exponents don't matter?
No, you're just combining like terms. So once you're combining, you're just looking at their coefficient. The exponents lets you know who combines. Okay. All right. So your turn to try. Go.
So wait, where's that?
At the bottom.
Oh, we were doing this. Oh.
Quickly, and then check with your group. All we're doing again. The variables aren't changing. The variables are just telling you who combines with who. The power is just telling you that goes together. They don't change anything. So notice here, our power is so it's who combined with what? What? So notice you didn't line them up perfectly, but I'm put this underneath AB, right? Because they track the same variable. Once you're lined up, all that matters is your coefficients. Okay.
1 plus 3 is 7. 4 plus 3. So wait, so how do we combine like something?
Go back. I don't know how to do this. Okay, what's up? I'm not. You don't do anything with them. They stay the same. The exponents tells you who goes with who. Who's part of your family. So you have an S to the third family. Is there another S to the third? And it's alone.
6 plus 5 is 12. Miss, you know I had a white
6 plus 5 is 12.
Oh, yeah.
Congratulations.
It's 11. 6 plus 6 is 12.
Yeah.
That's me waiting for the break.
All right, let's go over this quickly. All right, remember the variables are telling you who go together. Okay. So when you look at the first one, is there anyone that goes with this one?
Yeah. First one, right?
Where's another s cubed at? Nowhere. So it's a standalone. Okay. Does that make sense? Is there anyone that goes with 2s? Is there a single s? Yes. So you have positive 2s and positive 1s. What does that make? 3s. Is there anyone that goes with negative 3?
Yeah.
Yes, it is going to be 7. So negative 3 and positive 7 make 4. And then negative, this guy has nobody. It does not. Usually you put it in like, like sentences or certain order. Yes. So the best answer would be negative 4s to the third minus 2s squared plus 3s plus 4. Because you put it in order of the power. Okay. On the next one, again, you're asking yourself, where are all my p cubes at? Any other p cubes? No. Where are all of my single p's at? Well, I have negative 6 and negative 5. How many single p's do I have? Negative 11. I have p squareds. How many p squareds do I have? I have positive 11 p squared. And then my constant, does it have any friends? Nope, it's by itself. So if you want to write it correctly, ap to the third plus 11p squared minus 11p minus 11 would be the best answer. Okay? No, it stays the same. It literally tells you the 3 things we're learning at the top of your notes.
Oh.
Oh my God.
All right, on to part 2. Part 2 is subtracting.
I know. Subtracting.
2, 1, 2.
At the top of your notes, Jalen. Very top.
We're on part 2.
We're on part 2. So open up your booklet and turn it because remember your teacher did it upside down. The only difference between adding and subtracting is that before you can start combining like terms, you have to distribute your negative, okay? You have to distribute the subtraction. So the only difference is that you have to distribute the negative before you combine like terms. So notice here we have 2x squared plus x minus 4 minus x squared minus 4x plus 1. I'm going to have to distribute this negative every term inside. Yeah. Okay. So this is going to become a negative x squared, right? Does that make sense? So it's negative x squared. This is going to become a positive 4x, and this becomes a negative 1. After that, all it comes down to is combining like terms, okay? So I have 2x squared and negative 1x squared. What does that make? X squared. I have x and I have 4x. What does that make? 5x.
Oh.
Positive and a positive.
Oh, I thought you were talking about the negative.
And then we have negative 4 and negative 1, which makes negative 5. Yes? So the only difference here is before you can do anything, you have to distribute. So let's do it again, and then guess whose turn it is? Yours. Okay? So again, we're going to distribute the negative first. Distribute. Distributing the negative just means it's changing the signs. For the vertical method, instead of writing it next to it, you're going to write it below where it's like terms are. So my positive 2y squared becomes a negative 2y squared. My negative 4y becomes a positive 4y. And my positive 3 becomes a negative 3. And now we combine vertically. Does that make sense? So you distribute and then you move them. So now you're not paying any attention to this. You're just now going to add vertically. You have 5 minus 2 is 3. You have 7 plus 4 is 11. And 8 minus 3 is 5. Yes. All right. Yes. Still with me? Guess whose turn it is?
Your turn.
Oh my gosh, you're so smart. I think on your notes, I accidentally put a plus sign, please. The first one should be a minus.
Teachers make it.
Teachers make mistakes because we're human. I am too. Can't wait to go to lunch.
Shut up, Josh.
Focus.
Yeah.
Focus, focus.
Bless me.
Bless you.
Thank you.
Bless you.
I'm done.
Okay, remember, distribute, then combine like terms. Like terms mean they have the same variable, same power.
Oh wait, is the first one supposed to be done horizontal?
You technically
Whatever, choose whichever way you want.
All right.
Don't you get a blessing from somebody else? And then I think you did some psychology.
What I did?
Can you technically bless yourself?
Oh, I have this since I was 4 years old.
Don't you have to get a blessing from somebody else?
I don't know. I think I heard my grandma do it one day, and I was always done it.
What if I leave it early?
That's pretty good.
I feel like I have. Don't you pray for yourself?
Yeah, but that's not-
Okay,
that's
there you
not-
go.
that's not a blessing.
You're asking for a blessing.
Well, if you marry somebody, you gotta ask for a prayer of blessing, so you can bless yourself.
I do. I've been doing it for 33 years, so I'm just gonna tell you. 33. All right, here we go. Let's see how we did. What happened?
I'm just
You can just keep it for fun. All right. Here we go. Are we ready? So you should have ended up with negative 2a and a positive 5, correct? Because you distribute, combine. So you have 3a squared minus a plus 10. How do we do? Well, ignore the language. He didn't mean that. Don't know why he did that.
But that's what I meant.
Okay, again, make sure you distribute the negative. So now we have a negative 5, right? D to the third. We have a negative 3D. And then we have a positive 4, but there's nothing for it to add to, right? So I distribute, combine. 6D minus 3D gives me 3D. Negative 10D cubed minus 5D cubed gives me negative 15D cubed. D squared had no friends. And plus 4 had no friends. Okay, so if we want to write it in the correct order, it'll be negative 15D cubed plus 3D squared plus 3D plus 4. Yes. I mean, just in that group.
Does the order matter?
It doesn't. It's gonna be really obvious when you're looking at it which one should be. But just for like, you know how a comma can make a difference? Or putting punctuation is grammatically correct. Putting in order is mathematically. All right. Okay. On to part 3. See how quickly this is rolling? Okay, tell me why. If you owe me $10 and then you owe me $5, how much do you owe me now? You distribute the negative. It's already a positive. So when you distribute it, it became a negative. Okay, it's all right. We're learning. All right, part 3, multiplying polynomials. Okay, so this is where it gets a little more involved. Okay, so for multiplying, there are 2 ways of doing it. You have your traditional distribution and you have box method. Whichever way is your preference is 100% up to you. I'm going to model both and then you'll go from there. Okay. So up first, we have 6x cubed times 3x squared minus x plus 10. What we're going to write is this is a monomial. I said what we're going to write is a monomial times a trinomial. Anyone takes a stab at why this is called? Mono means what? 1. So this is a 1 term times a 3 term. So it's a monomial times a trinomial. Okay. You have the option of just distribution, single distribution, or you have the option of box method. So distribution and box method for this one are going to pretty much be the same. It doesn't make a difference, but all you're doing is multiplying each one of these by the monomial, right? So we're going to distribute, doom, doom, doom. And when we distribute, we end up with 6x cubed times 3x squared minus 6x cubed times x plus 10. I did not make this box very big for myself. Plus 10 times 6x cubed.
Oh.
Yes? Because distribution means that you take the monomial and you multiply times each term on the inside. You have a whole box.
Times 6.
There's no split. There's no line on there.
Nope. Exactly. So how are we going to do the box method now?
Very carefully. Be creative. All right. What's 6 times 6? 6 times 3?
13. I mean 18.
What is x cubed times x squared? x5. Yes.
Oh.
Okay. Then we have -6. What is x third times x to the 1? X to the 4. And then 10 times 6 is 60x cubed.
Wait, how do you get the 3x squared?
Huh?
How do you get the 3x squared on top? On the other equation on the top one.
This one?
Yeah.
Because 6x cubed times 3x squared. We distribute.
Oh, so it doesn't go in?
We did. We distributed in there.
I'm done.
No, you just had a little brain fart. All right. So the other thing is box method. Literally, box method isn't necessary for this one. But I'm going to model it to show you. Okay. So the box method, it's based on how big is your problem. So for this problem, we have a 1/3. Does that make sense? It's a 1/3 because it's a monomial times a trinomial. So our box would be a 1/3. That means 1 unit by 3 units. Huh? It's a monomial, which is 1, times a trinomial, which is 3. So our box is a 1/3. Yes? So we have 6x cubed is our monomial, and we have 3x squared, -x, and 10 are our trinomial. And all you're doing is filling in the inside of the box. So again, either way, 6 times 3, do y'all remember biology? The box, Punnett squares.
This is talking about the periodic table.
I'm pretty sure I said Punnett square. Yep. Minus 6x to the 4. And then 60x cubed. Is it the same result? Yes. It's just visually, which one do you like? There you go. So that's why I show you both. You choose which one you prefer. Okay? All right. Next, we're going to go on to the next example. Our next example is a squared binomial. Exactly. It's a squared binomial, which means that it repeats itself. So it becomes 3x minus 4 times 3x minus 4. Yes? Are y'all with me? Okay. Again, when you learn how to multiply a binomial, your teacher may have referred to as the FOIL method. That just means double distribution. Okay. So for the FOIL method, you have 3x minus 4 times 3x minus 4, and it's your first term times your first term. That's what the F stands for. So 3x times 3x is what? 9x what? Squared. Your O stands for your outside terms times your outside term. What is 3x times negative 4? What kind of 12x? Negative 12x. The I stands for your inside. So negative 4 times 3x gives us. And then L stands for your last terms times each other. A negative times a negative is a positive. So we end up with 9x squared minus 24x. If you owe me $12 and then you owe me $12, you now owe me how much? $24, right? Language. Why is it so hard? You did not pay me. Okay. All right. In terms of a box method, again, it's based on the size of your polynomials. So this is a 2 by 2. Why is it a 2 by 2? It's a squared binomial. You have a binomial times a binomial. So when you make your box, it makes a 2 by 2. Okay. The values on the outside are going to be from your terms. So you have 3x and negative 4. You have 3x and negative 4. The inside is just multiplication. Row times column, row times column. And that's how we end up with, on the inside here, we have 9x squared, negative 12x, and positive 16. And then you combine like terms. So in this case, these are my like terms. So my answer is still the same, 9x squared minus 24x plus 16. And again, it is your choice on which way you evaluate it. Yes? No questions, comments, concerns? Okay. Here's yours. You decide. Which method do you want to do? Do you want to do distribution or do you want to do box method?
Distribution is FOIL, right?
Mm-hmm. Which one do you want to do? All right, raise your hand if you did traditional distribution, multi-distribution. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Raise your hand if you did the box method. 1, 2, 3. Okay. Oh, kind of split. All right, cool. So this time we had a binomial times a binomial. It's not a binomial square, but they both are binomials, right? I know that because they each have two terms. So therefore, for distribution, the FOIL quote unquote method does work. So if you chose this, you would have had 2x plus 3y times 7x minus 4y. First times first gives us 14x squared. Outside times outside gives us negative 8xy. Inside times inside gives us positive 21xy. And last times last gives us negative 12y squared. We consolidate by combining like terms, and you should have gotten 14x squared plus 13xy minus 12y squared. Remember, when you're combining like terms, that has nothing to do with the variables, just the coefficients. Okay? If you are a box person, so if you chose to use the box method, you were creating a 2 by 2, correct? Because it's binomials. So your 2 by 2 should look something like this. You have 2x and a positive 3y. You have 7x and a negative 4y. And then we fill in 14x squared, 21xy. Then we have negative 8xy, and we have negative 12y squared. And your like terms for this bad boy were right there. Do we still get the same answer? Yes, it's just whichever one feels the most comfortable to you. Got it? All right, let's try another one. So this time, let's talk about what you have. So now I have a what? There we go. We have a binomial times a trinomial. Yep, she did. Okay, which means that you have, if you are doing FOIL, it's not FOIL anymore. It's just multiple distribution. You have to make sure that x is multiplied to each term. Pew, pew. And you have to make sure that negative 5 is multiplied. If you choose to do the box method, what are the dimensions of your box? A 2 by 3. Okay, you're creating a 2 by 3. Go, and we'll see how we do. Okay, so for this one, for distribution, it just wasn't a binomial, so you couldn't just distribute it once. And they both weren't binomial, so you couldn't use FOIL, right? It is just multiple distribution, okay? You could do it in parts, but essentially you have to multiply everything by x and everything by negative 5. Does that make sense? And then combine your like terms. So when we have x times 4x squared, that's going to give us 4x cubed. Then we have x times 9x, which gives us
X squared.
9x squared. Then we have x times negative 1, which gives us negative x. Now we're going to go on to the 5 and distribute negative 5. So negative 5 times 4x squared gives us negative 20x squared. Negative 5 times 9x gives us negative 45x, and then negative 5 times negative 1 gives us positive 5. A lot of times when I'm doing multiple distribution, I end up doing vertical addition. The reason why is because it lines it up for me already. And then I just got to bring down the first. 4x cubed, 9x squared minus 20x squared gives me negative 11x squared, negative 1x, and negative 45x make negative 46. If you owe me $1 and then you ask to borrow 45, you now owe me $46. And then plus 5. Yes? Okay, if you chose to do the box method, you would have had a 2 by 3 box. So you would have had a 2 by 3. Okay, on the outside, you have your x and negative 5. You would have had 4x squared, 9x, and negative 1. And then again, to fill in, all you're doing is multiplying. X times 4x squared is 4x to the third. X times 9x is 9x squared. X times negative 1 is negative x. 4x squared times negative 5 is negative 20x squared. Negative 5 times 9x is negative 45x. And then negative 5 times negative 1 is positive 5. Good job. Typically in the box method, as long as you're in order, like terms are going to be diagonal from one another. Do we still end up with the same answer? Yes. Okay. It is 100% up to you which way you choose to do it. Got it? All right. Now, this one is just to show you that when you have multiple polynomials being multiplied, you only can do 2 at a time. Okay. So you're going to evaluate those 2 and then go back and multiply. Does that make sense? Okay. So whether you're going to do multiplication, whether you're going to do multiplication with distribution or box method is up to you, but just know that you're doing it twice. Does that make sense? Not once, but twice. So to get us started here, I'm going to start off with these 2. And I'm going to distribute. So when I distribute, I have c squared times c gives me c to the third then I'm going to have c squared times -3, which gives me -3c squared. Then we have 2 times c, which is 2c. And then we have 2 times -3, which gives us -6. Okay? So that one's done. So now I just have this. So to just keep it, surprising for y'all, I'm going to then switch to the box method. So now I have a 2/4. Does that make sense? So I have a 2/4 because I have a binomial times a polynomial. So switching to the box, just to show some diversity in our notes. Okay, so my binomial is 2c and a +1. My polynomial is c to the third, -3c squared, 2c, and -6. And all we're doing is filling in. Got it? C cubed times 2c, what do I get? There we go. 2c times -3c squared. -c cubed. 2c times 2c. 4c squared. C times c. 2c times -6 is? There we go. 1 times c cubed is? 1 times anything is going to be its self. So I'm just going to finish that out. Is that cool? That's what you're doing inside the book. At the end is where you add. You're going to combine your like terms. So my first pair of like terms are the, I said, It won't let me highlight. All right, here we go. That's a pair of like terms, correct? Then we have our second pair of like terms, right? And then we have our third pair of like terms. Does that make sense? How do I know they're like terms? Yeah. Kelly, every time you say you don't know, you said correct answers today, by the way. Just want to point out to you. Okay, so we have 2c to the 4th. How many c3s do I have? I have 1 and -6. What does that make? -5. How many c squareds do I have? 1. How many c's do I have? -10. And then -6 had no friends. And that would be our final answer. Okay. So for me, when I don't know if I just like the change up, but I do like to do the distribution for the first pair. And then for whatever reason, my brain say, let's switch it up and do box method for the next. Okay. Oh, sorry. The last ones on your notes are for practice. And we did it. What?